Hi everyone, today's Leetcode question got how to rob a tree. So in this question, we are giving the house we want to rob in a tree form. And what's special about this question? Well, if we choose to rob a specific house, we cannot rob the child node of that house, but we can rob the child node of the child node of that house. But if we choose not to rob a specific house, then we can choose either to rob the child node of this house or not to rob the child node of this house. So let me show you how it means using example 1. So example 1, you see the root starting at this 3, right? So let me use drawing here using this red color. If we choose to rob this house, we cannot rob this house, right? Because these 2 and these 3 are the children of this root node. And now the only thing we can do is to rob the children of the children, which is this 3 and this 1. So if we choose to rob this house, we can rob these 3 houses altogether. So this will give us 3 plus 3 plus 1, which is 7. And what if we choose not to rob the root house? Then what will happen? They want to rob either the second level or the third level, right? So let's see, we rob only the second level. Then we get with 2 plus 3, we get 5, right? And you see this 5 is smaller than 7, so this is not a good idea. And finally, we can choose not to rob the child house and only to rob the children's children, right? So this 3 and this 1, which will give us 4. This is even smaller than this 5, right? So this is not optimal solution also. And the best solution we can get as shown in the question is 7, which means we rob this house, this house, and this house. Okay, I think the problem description is quite straightforward. Now let's think about how to solve this problem. So when you see this tree kind of structure, the first strategy to come to mind is depth first search, where you are traversing all the way down the end. If that idea doesn't work, you want to go back to the previous level. So let me use a drawing here using example 1 on the right side to help me understand. Okay, so let me draw the tree first, and then I'll spin. Okay, so here's 3, 2, here was 3, and 2 have 3 as a node, and this 3 have 1 as a node. Okay, and for in this question, since we can rob either without that node or with that node, so I want to initialize the list containing this variable. So let's say if we rob this node, we get with root, right? And if we don't run, we get without root. Okay, so this is the left side and this is the right side. Okay, now I want to start from bottom to top. And let's starting with this node. If we rob this node, then we get a 3, right? And if we don't rob this node, since this node do not have any child, we get only 0. Okay, and for this node, similarly, we can get 1 and 0 as well. Now with all node at this level, right, they want to go back to the previous level, so at this level. And at this level, the left side, we get 2. If we rob this node, then we cannot rob this 3, right? So the value we get from this one with 2. And if we choose do not rob this node, then we can either rob this node or do not rob this node. So we get the maximum between 3 and 0, right? And if simplifies this equation, this will give us 3. Okay, so that's the right 3 here. Okay, now finish this node. Let's go to the right node. So you see right node is 3. And for these 3, again, we can either include this node or not include this node. So if we include this node, we cannot include this node, right? So the only thing we get is 3. And if we choose do not include this node, we want to get a maximum between including this node or not. The maximum between 1 and 0. So simplify this one, and it will give us 1. Okay, finally, we reach all nodes at this level, right? And want to go back to the root level. So now we're right at this node. And at this node, the situation is slightly complicated, but don't worry, let me explain. So we choose to rob this node, then we get the value from rob this value, which is 3, and not rob this node, so we get 3. and also not rob this node, so we get 1. Okay, so simplify this one, it will give us 7, right? Okay, so write 7 here. And what if we do not rob this node? Then we can either rob this node or not, and either rob this node or not, right? So for the left side, we want to find the maximum between 2 or 3. And for the left side, we want to find the maximum between 3 and 1, right? And want to add them together. So this one will give us 3. And the right side will give us a 3 also. So 3 plus 3 is a 6. So write 6 here. Okay, now finish visiting the entire tree, right? And the final thing you want to do is find the maximum between this one and this one. And of course, you see 7 is greater than 6. So the only thing we need to do now is to return this 7 as the maximum value we can drop. Okay, now finish the graphical explanation. I hope it makes sense. Now let's dive into the coding part. Okay. So first, let me skip this main function and write helper function, and we did in previous 3 questions. So for the helper function, we actually need a root as the only variable. And the first thing we have to consider is to check the left and right recursively, and then want to split into the case with root or without root. Just copy paste this coding comment, save time. So the left is sub the helper, root of the left, and right is sub the helper, and root the right. And for the case with the root, of course, we include the root of L, and the left should be without root. So let's say we have this scenario, we have a list, right? We put with root in the first case and without root in the second case. So in Python, this indentation is 0 and this indentation is 1. So if we do not rob the left node, it will be a left 1 as well. The same for right 1 as well. And if we choose not rob that specific root, the selection will be our greater choice. So it will be the maximum between left 0 and left 1, because we can either rob the left node, plus the maximum between right 0 and right 1, because we can also either rob right or not. Okay, now finish that. The final thing to return a list containing with root and without root. So just copy paste here. Okay, so no need this anymore. And there's another thing to consider for the helper function, which is corner cases. So if we get a tree without root, then want to immediately return 0, 0. This means we cannot rob anything, right? Okay, now finish the helper function. Let's think about how to run the main function. Well, the main function is actually very simple. You see the helper function while returning this with root and this without root, right? So the only thing we want to do is find the maximum between the helper function output, called helper function, passing root, and find the maximum between these two values and just return this value. Okay, now let's submit the code to see it works. Okay, you see the time capacity and memory usage of this solution is quite efficient, right? And I think the coding part is very easy to understand. If you find this helpful, please like this video and subscribe to my channel. Thank you for watching and see you next time.